What if the greatest discovery in human history is also a death sentence for our species? For millennia, we have stared into the void, asking a single profound question: are we alone? That question was answered not by a signal from a distant star, but by a whisper from our own backyard. In the cold, silent expanse of Mars's Jezero crater, at a site designated Bright Angel, the Perseverance rover drilled into ancient rock, and the data it sent back would forever alter our place in the cosmos. It was not a vague chemical hint or a statistical probability. It was a tangible, physical artifact, a delicate filigree of millimeter-scale mineral rings, iron phosphate and iron sulfide, interwoven with complex organic molecules. On Earth, this exact chemical and structural signature is an unambiguous testament to life, the fossilized footprint of microbial metabolism. A triumphant discovery was announced to the world, but in the quiet halls of cosmology and astrobiology, a deep and unsettling silence began to fall. The clue shouldn't just exist, it should be celebrated, but it felt less like a discovery and more like a verdict. The impossibility of the Martian clue lies in its precision. Every known abiotic process that could mimic such a formation was meticulously ruled out by the surrounding geology. There was no evidence of the extreme heat, the specific volcanism, or the unique acidic conditions required to forge these minerals without life's intervention. The data was checked, rechecked, and confirmed. It was an elegant, undeniable biosignature. For the first time, we had proof that the miracle of life, the most complex phenomenon known to science, was not a singular event confined to our world. It had happened twice, in one solar system, on two neighboring planets. This revelation should have been the dawn of a new era of cosmic optimism, a confirmation that the universe is fertile ground for biology. Instead, it was the sounding of a funeral bell. The discovery of simple, long-dead microbes on Mars may have inadvertently solved the greatest paradox of all, and in doing so it may have sealed our fate. The search for extraterrestrial life was over, but a far more terrifying investigation was just beginning. From this profound revelation, the great chilling question emerges, the one that now haunts the minds of those who understand its full weight. Have we just found the great filter? This is the central thesis of our investigation. The universe, as we will explore it, is a crime scene, and the victim is intelligent life itself. For decades, we have puzzled over the Fermi paradox, the deafening silence from a cosmos that should be teeming with civilizations. The discovery on Mars provides the critical missing piece of that puzzle. It suggests the filter, the immense barrier that prevents simple life from becoming a star-faring civilization, is not behind us. It is not the rare genesis of life, the improbable leap from non-living matter to biology. That step, it now seems, is common. The horrifying implication is that the filter must, therefore, lie ahead of us, somewhere between our current technological adolescence and a future we may never reach. Our journey will not take us to the distant stars in search of aliens. Instead, it will lead us deep into the past of two worlds, treating their geological records as two parallel case files in a cosmic inquest. We will sift through the evidence left behind in stone and ice, comparing the planet that lived with the planet that died. We will listen to the great silence of the cosmos, not as an absence of evidence, but as evidence of absence, a clue as powerful as any fossil. We will even turn our gaze inward, to the echoes of premonition in our own myths and cultures, the ancient warnings of hubris and self-destruction that seem baked into our species' consciousness. The map of our journey is a search for a ghost, a barrier that is so efficient and so final that not one single civilization in the history of our galaxy appears to have survived it. The evidence from Mars has narrowed the list of suspects, and what remains points to a conclusion that is both deeply unsettling and inescapably logical. To comprehend the scale of this mystery, we must first understand the paradox that defines it. In 1950, during a casual lunch conversation, the physicist Enrico Fermi posed a simple yet world-altering question. Given the age and size of the universe, the hundreds of billions of stars in our galaxy alone, and the high probability of Earth-like planets, our galaxy should be filled with civilizations, many of them millions of years older than our own. They should have had ample time to colonize the stars, leaving behind unmistakable signs of their existence. Yet, when we look and listen, we find nothing. No signals, no megastructures, no probes. Just a vast, silent, and seemingly empty expanse. This is the Fermi paradox, the stark contradiction between the high probability of extraterrestrial life and the complete lack of evidence for it. The universe is screaming its potential, yet the stage remains empty. Fermi's question, "Where is everybody?" has become the greatest detective story in the history of science. The most compelling and most sobering proposed solution to this paradox is the concept of the Great Filter. The theory posits that on the long evolutionary path from simple life to a galaxy-spanning super-civilization, there exists at least one step that is so improbable, so difficult to overcome, that almost no species ever makes it past. This step is the Great Filter. For decades, humanity held on to a comforting hope about its location. We hoped the filter was behind us. Perhaps the initial spark of life, the process of abiogenesis, was the filter. This would make us the first, the lucky ones who won a cosmic lottery. Or perhaps the leap from simple prokaryotic cells to complex eukaryotic cells was the barrier, a fluke of biology that rarely happens. In either scenario, we were special. We had passed the test that silenced the rest of the universe. The silence of the cosmos wasn't a graveyard, it was simply an empty wilderness waiting for us to populate it. The fossilized microbes of Bright Angel have systematically dismantled this comforting worldview. The discovery on Mars is a fatal blow to the idea that the origin of life is the Great Filter. If life could begin independently on two adjacent planets in the same star system, it cannot be an impossibly rare event. It suggests that the universe is, in fact, primed for biology. The raw materials are everywhere, and the process to ignite them into simple life may be a common, almost inevitable outcome of planetary evolution. This is the terrible inversion of our hopes. The good news we so desperately wanted to hear, that life is common, has become the worst news imaginable. It means the Great Filter is not in our deep past. It is not a hurdle we have already cleared. By proving that the first step is easy, we have been forced into the horrifying realization that a later step must be catastrophically hard. This forces us to re-examine our own planetary history through a darker lens. Earth has endured at least 5 great mass extinctions, catastrophic events that wiped out the majority of all species. We have always viewed these as immense hurdles that life, through sheer tenacity, managed to overcome. But what if we have been misinterpreting the evidence? Life on Earth survived asteroid impacts, global volcanic winters, and dramatic climate shifts. Complex life arose, intelligence bloomed, and technology was born. Our planet's history demonstrates a remarkable resilience. It proves that even planetary-scale disasters are survivable. This means that a mere asteroid or supervolcano is unlikely to be the Great Filter. Life, once it takes hold, is stubborn. The filter must be something more insidious, something that even a resilient biosphere cannot withstand. It must be a challenge that arises later in a civilization's development. The logical conclusion is inescapable. If the genesis of life is not the filter, and planetary catastrophes are not the filter, then the barrier must lie somewhere in the gap between our current level of technological achievement and a stable interstellar future. We are standing in the most dangerous place in the universe, the very stage of development where the filter is most likely to be active. The silence of the cosmos is not the silence of worlds where life never began. It is the silence of worlds where intelligence arose, developed technology, and then, through some inevitable process, annihilated itself. We are not the first to walk this path. We are simply the next in line to face a test that, based on the available evidence, no one has ever passed. The message from the stars is a chilling one. The moment a species becomes powerful enough to ask, "Are we alone?" it is already on the verge of ensuring that it will be. To truly grasp the implications, we must recalibrate our understanding of time itself. Human civilization, with its recorded history of a few thousand years, is a fleeting whisper in the grand saga of the cosmos. We must learn to think in what geologists call deep time. If the entire 4.5 billion year history of the Earth were compressed into a single 24-hour day, all of human history would flash by in the last second before midnight. Civilizations could have risen and fallen on Earth in the deep past, and their traces would be all but erased by the relentless churn of plate tectonics, erosion, and deposition. Our civilization that lasted for 100,000 years, 20 times longer than our own recorded history, would still be a geological blink of an eye. This is the timescale on which we must conduct our investigation. We are not looking for pyramids or statues. We are looking for ghosts in the rock. This brings us to the concept of techno-signatures, the subtle, long-lasting evidence that a technologically advanced civilization would leave behind in the geological record. What would the footprint of our own industrial age look like to a geologist 100 million years from now? They would find a sudden spike in carbon isotopes from our burning of fossil fuels, a thin layer of microplastics distributed globally, and unusual concentrations of synthetic molecules and radioactive isotopes that could not have been produced by nature. These are techno-signatures. They are the chemical and geological fingerprints of intelligence. The Silurian hypothesis, proposed by scientists Gavin Schmidt and Adam Frank, asks this very question. If an industrial civilization existed on Earth millions of years ago, what traces would it have left for us to find? This provides a framework for our search, not just on Earth but on Mars as well. Our investigation, therefore, begins with two primary crime scenes, Earth and Mars. They are two witnesses to the history of life in this solar system. Earth stands as Exhibit A, a vibrant, living world that tells a story of survival and success against all odds. It is the control case, a planet that has seemingly overcome every natural obstacle thrown in its path, from the faint young sun to devastating asteroid impacts. Mars, on the other hand, is Exhibit B, a planetary tombstone. It is a world that passed the test of Genesis, but failed the test of endurance. Its fossil record shows that life began, but then it stopped. The cold, dry dust of Mars holds the key to understanding failure, a silent monument to a biological experiment that was terminated billions of years ago. The stark contrast between these two worlds will form the first pillar of our case. Beyond these two planets, our investigation will expand to the cosmic scale. We will turn our instruments to the sky and analyze the great silence itself. The decades-long search for extraterrestrial intelligence, or SETI, has yielded nothing but an echoing void. This is not a failure of the search. It is a critical piece of negative evidence. We will then examine the atmospheres of distant exoplanets, where advanced telescopes can now hunt for the chemical fingerprints of industry on a galactic scale. We are searching for anomalous levels of pollutants, like chlorofluorocarbons, or the faint heat signatures of alien megastructures. The profound and pristine cleanliness of the cosmos is a clue in itself. It suggests that civilizations either do not reach an industrial stage, or they do not last long enough to leave a permanent scar on their environment or the galaxy. The silence is not empty, it is a graveyard. This is the journey we are about to embark upon. We will connect the dots between a fossil on Mars, the geological history of Earth, the pristine atmospheres of distant worlds, and the deepest fears encoded in our own myths. The evidence, when assembled, will point toward a single, cohesive, and deeply sobering conclusion about our own future and the nature of intelligent life in the universe. We are treating this as a formal investigation, presenting the clues one by one, and we invite you to be part of the jury. This is not a story of distant aliens or speculative fiction. It is a story about us, pieced together from the hardest scientific data available. It is a story that begins with a monumental discovery and ends with a profound question about our own survival. If you are a fellow explorer of forgotten histories, ready to question everything, support our journey by hitting the like button, subscribing, and letting us know in the comments where in the world you are watching from. The case is now open, and the first piece of evidence has been presented. A single fossilized microbe on a distant world has just put all of humanity on trial. Now, the investigation truly begins as we place Earth and Mars side by side to understand what it takes for a world to live and what it takes for a world to die. Our investigation begins not by gazing outward into the void, but by turning our focus inward to the only successful biological experiment we know for certain, our own planet. Earth is our prime witness, a living testament to survival against impossible odds. Its geological record is a vast and complex library, written in layers of stone and ice, chronicling billions of years of trial and error. For generations, we have read this history as a story of our own exceptionalism, a series of fortunate events and narrow escapes that allowed our species to emerge. We saw the great extinctions as cosmic bullets we were lucky enough to dodge. But the discovery at Bright Angel forces us to reread this entire history with a chilling new perspective. What if Earth's story is not one of luck, but one of profound, terrifying resilience? What if our planet's archives prove that life is not a fragile flame, but a raging fire that, once lit, is almost impossible to extinguish by natural means? This reinterpretation is the first step in our inquest, for if life can survive the worst that nature can throw at it, then the great filter must be something else entirely. It must be something unnatural. To test this hypothesis, we must journey back 252 million years to the end of the Permian period, a time when life on Earth was arguably more diverse and established than it is today. The continents were fused into the supercontinent of Pangaea, and the world was a tapestry of strange and wonderful ecosystems, from vast fern savannas to sprawling coral reefs. This was a mature, stable biosphere. Then, in a region now known as the Siberian Traps, a wound in the planet's crust opened, and it began to bleed fire. For nearly 1 million years, a flood of basaltic lava, covering an area larger than modern-day Europe, poured onto the surface, releasing a catastrophic volume of carbon dioxide, methane, and sulfur dioxide into the atmosphere. This was not a singular event like an asteroid impact. It was a slow, agonizing planetary poisoning. The oceans warmed and turned acidic, dissolving the shells of marine creatures. As oxygen levels plummeted, vast anoxic dead zones spread, suffocating the seas from the inside out. On land, acid rain stripped forests bare, leading to mass erosion that choked the rivers with sediment. This was the Great Dying, the most severe extinction event in our planet's history. The sheer scale of the Permian-Triassic extinction is difficult to comprehend. It was a biological apocalypse that came terrifyingly close to sterilizing the entire planet. Over 96% of all marine species and 70% of terrestrial vertebrate species were wiped from the face of the Earth. The intricate web of life, built up over hundreds of millions of years, was systematically dismantled. The world fell silent. For millions of years afterward, the planet was a ghost of its former self, dominated by the hardiest and most opportunistic survivors, like the hardy Lystrosaurus, a pig-sized herbivore that for a time made up 90% of all land vertebrates. This event serves as our ultimate test case for a natural filter. If anything could qualify as a great filter of planetary scale, it would be this slow, systemic collapse of the entire biosphere. It was a perfect storm of geological and chemical warfare waged against life itself. Yet despite being brought to the very brink of annihilation, life did not break. It clung on in the margins, in the refuges, and when the planet's fever finally broke, it began the slow, arduous process of rebuilding. The survival of life through the Great Dying is perhaps the most crucial piece of evidence in our entire investigation. It tells us that even a planetary-scale, million-year-long cataclysm, one that fundamentally rewrites the chemistry of the atmosphere and oceans, is not an absolute filter. It is a bottleneck, an immense evolutionary trial by fire, but it is survivable. Life as a planetary phenomenon is stubbornly persistent. It adapts, it endures, and it recovers. The same can be said for the other major mass extinctions in Earth's history, including the asteroid impact that wiped out the dinosaurs. Each was a devastating blow, but in every case the biosphere eventually bounced back, often with renewed vigor and diversity. This pattern of destruction and recovery forms the backbone of our first conclusion. Natural disasters, no matter how catastrophic, are unlikely to be the great filter. The silence in the cosmos is probably not due to a prevalence of asteroids or supervolcanoes. If life on Earth could withstand these events, it is reasonable to assume that life on other worlds could as well. This forces our investigation deeper into stranger and more unsettling territory. If the filter isn't a natural disaster, what is it? Our journey now takes us from the dramatic evidence of mass extinctions to the more subtle, almost invisible clues hidden within the Earth's chemical history. We are searching for ghosts in the geological data, for anomalies that do not fit the natural patterns of our planet's past. This is the core of the Silurian hypothesis, which posits that if an industrial civilization existed in the deep past, its most enduring legacy would not be fossilized cities, but a distinct chemical fingerprint left in the sedimentary layers. Our own industrial age is currently etching such a fingerprint into the rock. The massive quantities of carbon we release by burning fossil fuels are isotopically different from the carbon already in the atmosphere. Fossil fuels are derived from ancient plant life, which preferentially absorbs the lighter isotope, carbon-12. When we burn them, we flood the atmosphere with this lighter carbon, creating a distinct negative shift in the global carbon-13 Saturn carbon-12 ratio. Our geologist 100 million years from now would see this spike as a clear, unambiguous sign of a global event unlike any other in the geological record, a technosignature. With this framework in mind, we turn our attention to one of the most enigmatic events in our planet's history, the Paleocene-Eocene thermal maximum, or PETM, which occurred around 56 million years ago. The geological record from this period shows a sudden and dramatic event. Global temperatures surged by 5 to 8 degrees Celsius in just a few thousand years. A geological instant. The oceans became highly acidic, leading to a mass extinction of deep-sea organisms. And crucially, this event was accompanied by a massive negative carbon isotope excursion, a huge injection of isotopically light carbon into the atmosphere and oceans. The pattern is eerily familiar. The scale and speed of the carbon release during the PETM are remarkably similar to the projections for our own future anthropogenic emissions. This is the anomaly. This is the geological ghost. It is a moment in Earth's history that looks, chemically, like the footprint of a global industrial civilization. The orthodox scientific explanation for the PETM involves massive volcanic eruptions igniting vast coal seams or the sudden release of methane hydrates from the ocean floor. These are plausible natural mechanisms. However, many models struggle to account for the sheer speed of the carbon injection required to match the geological data. The event seems too fast, too abrupt, to be fully explained by the slow geological processes that are typically invoked. This is where the Silurian hypothesis offers a radical alternative lens through which to view the evidence. What if the PETM was not a purely natural event? What if we are looking at the chemical scar left behind by a previous, short-lived industrial civilization that rose, industrialized, and collapsed millions of years before the first hominids walked the earth? It is a speculative and unsettling thought, but one that the chemical data itself forces us to consider. The PETM is not proof, but it is a haunting possibility, a data point that stubbornly refuses to fit neatly into our established narratives of Earth's history. Of course, a carbon isotope anomaly alone is not enough to build a case. A true industrial civilization would leave behind other, more specific traces. We would expect to find unusual concentrations of synthetic molecules, plastics, or long-lived radioactive isotopes from nuclear activity. The search for these unnatural molecules in the PETM sediment layers has so far yielded nothing. However, this absence of evidence is not necessarily evidence of absence. Over 56 million years, the relentless churn of plate tectonics, subduction, and erosion would destroy almost all direct physical artifacts. Complex synthetic molecules would likely break down, and even plastics might not survive in a recognizable form. We would be left with only the most fundamental and widespread evidence, like the global carbon signature. The mystery of the PETM therefore remains. It is a tantalizing and deeply unsettling event that demonstrates how a civilization's footprint could be almost entirely erased, leaving behind only a faint chemical echo, a whisper of industrial activity in the deep time record. It serves as a profound warning about our own potential for geological impermanence. The PTM is not the only such event. Geologists have identified several other hyperthermal events in Earth's history, smaller but similarly abrupt warming periods associated with carbon cycle disruptions. Each of these represents a puzzle, a moment when the planetary system was thrown out of equilibrium by a rapid release of greenhouse gases. While most can be plausibly linked to large-scale volcanic activity or orbital cycles, they collectively paint a picture of a planet whose climate is more volatile and susceptible to rapid shifts than we once believed. This context is crucial. It means that if a prior civilization existed, its industrial activity might not even stand out as a completely unique event, but could instead be masked by a background of natural climatic volatility. It would be like trying to find a single, deliberately set fire in the aftermath of a massive forest fire caused by lightning. The signal could be lost in the noise. This makes the search for past civilizations on our own planet an incredibly difficult forensic challenge, one that requires us to look for the faintest of signals amidst a background of immense natural chaos. This brings us to a critical juncture in our investigation. The geological history of Earth has shown us two profound truths. First, life as a whole is incredibly resilient, capable of surviving even the most extreme forms of natural planetary catastrophe. The Great Dying was a filter, but not an absolute one. Second, the geological record is vast and imperfect, and the footprint of a short-lived industrial civilization could be incredibly subtle and difficult to distinguish from natural events, as the mystery of the PETM demonstrates. Earth, our witness to success, has proven itself to be a survivor. It has endured the worst the cosmos and its own geology could throw at it. To truly understand what this means for the Great Filter, we must now turn to our other witness, the one that did not survive. We must travel 400 million kilometers away and examine the geological record of a planet that also began with the promise of life, but ended in silence. Mars. To understand Earth's success, we must first intimately understand Mars's failure. 4 billion years ago, Mars was a very different world. It was a planet of liquid water, with vast oceans, winding river deltas, and a thick atmosphere capable of supporting a stable climate. Evidence for this ancient watery past is etched all over its surface, from the dry riverbeds of the North Vallis to the mineral signatures of clays and carbonates found by our rovers, which could only have formed in the presence of abundant water. Most importantly, it had a global magnetic field, generated by a molten iron core, just like Earth's. This magnetic shield was crucial, protecting the young planet's atmosphere from being stripped away by the harsh solar wind. By all accounts, early Mars was a habitable world, a second cradle for life in our solar system. The fossil at Bright Angel is the definitive proof that this potential was realized. Life did begin on Mars. The story of Mars is the story of a slow, inexorable death. Unlike the sudden catastrophes that Earth endured, Mars suffered a systemic, internal failure. Sometime around 4.1 billion years ago, the planet's core began to cool and solidify. As the molten iron dynamo churned to a halt, the planet's protective magnetic field vanished. This was the fatal blow. Without its magnetic shield, the solar wind, a relentless stream of charged particles from the sun, began to sandblast the Martian sky away, molecule by molecule. The atmospheric pressure plummeted. The liquid water on the surface either boiled away into space or froze solid, locking itself into the polar ice caps and the subsurface permafrost. The planet grew cold, dry and sterile. The nascent biosphere, which had just begun to take hold, was left exposed and unprotected. Life may have clung on for a time in underground aquifers or geothermal vents, but eventually the planetary life support system failed completely. Mars became the frozen red tombstone we see today. The death of Mars represents a different kind of filter, one that is not an external shock, but an internal, systemic failure. It is the filter of planetary infertility. A planet must not only be in the right place, the habitable zone, but must also possess the right internal characteristics: a large enough size to retain a molten core, active plate tectonics to recycle carbon, and a stable magnetic field, for billions of years to allow complex life to evolve. Mars failed this endurance test. It passed the test of abiogenesis, the origin of life, but it failed the long-term test of habitability. For a long time, this was considered a strong candidate for the Great Filter. Perhaps very few planets have the geological stamina to remain habitable for the immense timescales required for the evolution of intelligence. It's a powerful argument, and the fate of Mars is its primary exhibit. However, the very existence of Earth stands as a powerful counter-argument. Our own planet is not exceptionally large, and its own history has been fraught with geological instability. We have endured periods of intense volcanism, ice ages that covered the globe, and dramatic shifts in atmospheric composition, like the Great Oxidation Event, where early photosynthetic life poisoned the atmosphere with a corrosive gas, oxygen, triggering a mass extinction of the anaerobic life that preceded it. Earth, too, has faced systemic challenges that could have led to a Martian fate, but it survived. Its internal systems, like the carbon cycle regulated by plate tectonics, acted as a planetary thermostat, pulling it back from the brink time and again. Life on Earth did not just inhabit the planet, it actively participated in regulating its climate, co-evolving with the geosphere in a way that maintained long-term stability. The comparison between the two worlds is stark. Mars is a story of a system that failed, while Earth is the story of a system that, through a combination of geological luck and biological resilience, succeeded. This direct comparison between the two planetary case files leads us to a sobering conclusion that refines our search for the Great Filter. The evidence shows that both external catastrophes, like the Permian extinction, and internal systemic failures, like the death of Mars's magnetic field, are indeed powerful filters. They undoubtedly wipe out countless nascent biospheres across the galaxy. However, Earth stands as definitive proof that both of these types of filters are survivable. Life on our planet overcame them all. We are the living descendants of organisms that survived planetary poisoning, global freezes, asteroid impacts, and fundamental shifts in atmospheric chemistry. This means that while these natural hurdles are immense, they cannot be the final or great filter. The profound silence of the cosmos cannot be fully explained by planets that simply go bad or get hit by rocks. There must be another, even more formidable barrier that stands between a resilient biosphere like ours and a galaxy-spanning civilization. Of all the geological and fossil evidence we've uncovered so far, which piece do you find the most compelling? Is it the sheer, brutal resilience of life demonstrated by its survival of the Great Dying, or is it the subtle, haunting mystery of the PETM, with its chemical echo of a possible forgotten industrial age? Let us know your thoughts in the comments. This methodical elimination of natural causes forces our investigation forward. We have examined the evidence in the rock and found that nature, while powerful, does not seem to build a wall that is insurmountable. The suspect list for the Great Filter is shrinking. We have now ruled out the genesis of life thanks to the Martian fossil, and we have now, with a high degree of confidence, ruled out planetary-scale natural disasters thanks to the testimony of Earth itself. The path is clearing, and it is leading us away from geology and paleontology and toward a far more uncomfortable domain, the study of intelligence and technology itself. The evidence from deep time suggests a chilling narrative. It tells us that the universe is likely filled with worlds where life begins, just as it did on Earth and Mars. Many of these worlds will fall victim to planetary failures, becoming barren tombstones like our red neighbor. But a certain fraction, the lucky and resilient ones like Earth, will survive. On these worlds, life will endure for billions of years, surviving every natural cataclysm the universe can muster. It will grow in complexity, eventually producing intelligence, consciousness, and the ability to manipulate the world on a global scale. These civilizations will emerge from their planet's long, violent history, having conquered every external threat. They will look out at the stars and ask the same question we do: where is everybody? The answer, implied by the evidence we have reviewed, is that they are all gone. They did not fall to an asteroid or a volcano. They fell to something that only emerged after they had achieved technological prowess. This is the terrible weight of the geological evidence. It acts as an alibi for nature. By demonstrating life's ability to survive the worst natural disasters, the rock record inadvertently points the finger of blame squarely at the victims themselves. The filter is not something that happens to a civilization. It is something that a civilization does to itself. This is the logical endpoint of our journey through deep time. We have followed the clues left in stone across 2 worlds, and they have led us to the threshold of our own age. The great extinctions of the past were filters that life passed. The planetary failure of Mars was a filter that Earth's biosphere passed. We are the inheritors of an unbroken chain of survival stretching back nearly 4 billion years. But the silence of the cosmos suggests this chain is about to be broken. The next filter, the great filter, is not buried in the deep past. It is waiting for us in the near future. The story written in the rocks of Earth is not, therefore, a comforting tale of our own specialness. It is a warning. It is the story of a witness who has survived multiple murder attempts by nature, only to now be facing a completely different kind of threat. When we look at the pattern, we see a potential echo of what happens when a planet's carbon cycle is thrown into chaos by a massive, rapid injection of greenhouse gases, a scenario we are actively replicating today. When we look at the resilience of life after the Great Dying, we are not seeing a cause for celebration, but a stark reminder that the challenges our own technology is creating, from nuclear proliferation to runaway artificial intelligence or ecological collapse, are of a kind that the biosphere has never before faced. These are not external shocks that life has evolved to withstand. They are internal, self-inflicted wounds for which there is no precedent in the entire 5 billion year history of our planet. Therefore, our first loop of investigation concludes here, with the Earth itself as the key witness. Its testimony, written in the language of isotopes and extinction layers, has been clear. It has told us that life is tough, planets can be fickle, and that survival against natural odds is a game that can be won. The evidence from Mars corroborates this, showing us what failure looks like, a warning from our own backyard. But this testimony only deepens the central mystery. If the journey through the natural world is so survivable for a lucky few like us, why is the galaxy so silent? The absence of any other voices forces us to a single, terrifying conclusion. The most dangerous thing in the universe is not a rogue asteroid, a nearby supernova, or a dying parent star. The most dangerous thing in the universe is achieving what we have just achieved, a globally interconnected, technologically advanced civilization. The geological record has shown us the path to this point. Now, we must look elsewhere to understand why this path seems to lead, always and inexorably, to a dead end. We leave the domain of deep time with a new, more refined question. It is no longer what natural event stops life from spreading, but rather what predictable act of self-destruction is committed by every technologically intelligent species. The Earth's rocks have given us the context and the scale of the problem. They have shown us the hurdles we have already cleared, the immense challenges that life has already overcome. This realization should fill us with a sense of dread, not pride. We are the graduates of the universe's harshest survival school, and yet the cosmos is telling us that the final exam is still ahead, and that no one, anywhere, has ever passed it. The evidence buried in our planet has served its purpose. It has eliminated the most obvious suspects and has forced us to confront the possibility that the killer we are searching for is, and always has been, ourselves. The investigation now moves from the ground beneath our feet to the silent, empty sky above. Our investigation now pivots from the grand, brutal theater of planetary extinctions to the subtle, almost silent world of forensic chemistry. We have established that life, as a planetary force, is a survivor, capable of enduring the worst that nature can inflict. This resilience is a critical clue, for it systematically eliminates natural disasters as the prime suspect for the Great Filter. If the killer is not an external force, we must look for evidence of an internal one. We must search for the chemical ghosts of industry, the faint, indelible fingerprints that a technologically advanced civilization would leave etched into the geological strata of its world. This is a search conducted not with hammers and chisels, but with mass spectrometers and isotopic analysis. We are looking for anomalies in the Earth's deep history that whisper of an unnatural past. moments when the planet's fundamental life support systems were tampered with by intelligent hands. We begin by examining the very air and water of the past, trapped in ancient ice and sediment, searching for a chemical echo that mirrors our own industrial age. Our first and most compelling exhibit lies buried in sediment cores drilled from the ocean floor dating back 56 million years. Here we find the chemical signature of the Paleocene-Eocene thermal maximum, or PETM, a brief, violent fever in Earth's history. During this event, global temperatures skyrocketed by as much as 8 degrees Celsius, and the oceans became so acidic that they dissolved the shells of countless marine organisms, leaving a ghostly layer of red clay in the deep sea record. The trigger for this catastrophe was a colossal injection of carbon into the atmosphere, but it was the types of carbon that constitutes the smoking gun. By analyzing the ratio of carbon isotopes, scientists discovered a massive negative spike, indicating the carbon came from a source depleted in the heavier carbon-13 isotope. This is the unmistakable signature of burned organic matter, the chemical residue of fossil fuels. The PETM was, in essence, a planetary carbon bomb, an event that looks disturbingly like the geological footprint our own civilization is creating right now. The parallel between the PETM and our current era, the Anthropocene, is as undeniable as it is disturbing. The scale of the carbon released during the PETM, estimated to be thousands of gigatons, is on the same order of magnitude as what humanity will release if we burn through our remaining fossil fuel reserves. More unsettling is the speed. The event, once thought to have unfolded over tens of thousands of years, is now understood by many studies to have been far more rapid, perhaps occurring in less than 5,000 years. This velocity presents a significant challenge to purely natural explanations. While the leading theories involve the volcanic baking of organic-rich sediments or the sudden release of methane hydrates from the seabed, many models struggle to replicate the sheer abruptness of the isotope shift. The PETM's chemical profile fits the description of a global industrial civilization burning through its planetary inheritance with reckless speed, a geological prelude to our own story, written 56 million years in the past. Of course, the scientific consensus has not embraced the idea of a lost industrial civilization as the cause of the PETM. The conventional explanations, while imperfect, remain the most parsimonious. They do not require us to invent a ghost in the geological machine. Yet the Silurian hypothesis compels us to treat this event as a legitimate line of inquiry. It forces us to ask, what other evidence would we expect to find? A true industrial society would leave more than just a carbon signature. It would produce novel synthetic materials and pollutants that have no natural source. The most obvious of these would be plastics, whose molecular chains are so resilient they are destined to form a distinct, identifiable layer in the future rock record. Geologists have even coined a term for it, a plastiglomerate, a fusion of rock, sand, and melted plastic. The search for such specific molecular fossils from the PETM era is a monumental challenge, but it is the necessary next step in this forensic investigation. The absence of a discovered plastic bottle or a fossilized microchip from 56 million years ago is, however, not the exoneration one might think. The Earth's crust is a relentless recycling system. Over such vast timescales, the processes of subduction, erosion, metamorphism, and microbial decay would obliterate nearly all macroscopic artifacts. A city would be ground to dust, and its materials reabsorbed into the planetary crust in a geological blink. Even our most durable synthetic polymers would eventually break down. What might survive, however, are the most chemically stubborn of their molecular components, persistent organic pollutants, or POPs. Molecules like polychlorinated biphenyls, PCBs, or dioxins are incredibly resistant to degradation. Finding a cluster of these complex, unnatural molecules in a PETM sediment core would be tantamount to finding a fingerprint at a 56-million-year-old crime scene. The search is on, but it is an endeavor akin to finding a single specific grain of sand on all the world's beaches. Beyond carbon and synthetic polymers, a truly global industrial civilization would fundamentally alter other planetary biogeochemical cycles. Consider nitrogen, the most abundant gas in our atmosphere. In its gaseous N2 form, it is largely inert and unavailable to most life. For eons, the amount of fixed biologically available nitrogen was tightly regulated by natural processes like lightning strikes and the metabolism of specific bacteria. This created a stable bottleneck for life on Earth. Then, in the early 20th century, humanity invented the Haber-Bosch process, an industrial method for synthesizing ammonia-based fertilizers from atmospheric nitrogen. In a single century, we have doubled the amount of fixed nitrogen circulating in the biosphere, an intervention on a scale that rivals our disruption of the carbon cycle. This industrial nitrogen fixation leaves its own distinct isotopic signature in sediments, a clear marker of technological interference in a fundamental planetary system. This presents another testable hypothesis. If the PETM was the result of industrial activity, it should have been accompanied not only by a carbon isotope anomaly, but also by a corresponding nitrogen isotope anomaly. The geological record of that period should show evidence of a massive, unnatural fertilization of the planet, leading to widespread ocean anoxia and ecosystem collapse, precisely what was observed during the event. Early investigations into the nitrogen cycle of the PETM are underway, and while the data is still complex and subject to multiple interpretations, it represents a new frontier in the search for techno-signatures in deep time. We are no longer just looking for the exhaust fumes of a past civilization. We are looking for its agricultural runoff, its industrial waste, the full chemical footprint of a biosphere hijacked by technology. Each planetary cycle we examine becomes another potential witness, another page in the geological police report. Let us now consider the most unambiguous of all potential techno-signatures: artificial radioactive isotopes. Our own nuclear age, beginning in the mid-20th century, has dusted the entire planet with a thin layer of isotopes like plutonium-244 and curium-247. These elements do not occur in any significant quantity in nature and have half-lives of 80 million and 15.6 million years, respectively. This means that if a civilization existed 56 million years ago and experienced a nuclear age, either through power generation or warfare, the faint radioactive echo of their activities would still be detectable today. A spike of these specific transuranic elements in the sedimentary layer corresponding to the PETM would be irrefutable proof. To date, no such spike has been found. This is perhaps the strongest piece of evidence against the PETM being the death knell of a Silurian civilization like our own. However, this absence of evidence only refines our question. It does not eliminate it. It suggests that if a civilization existed, it may not have developed nuclear technology, or at least not on a scale that left a global footprint. Perhaps their industrial revolution was based on a different energy source, or perhaps they collapsed before ever splitting the atom. The filter that caught them might have been purely ecological, a runaway greenhouse effect from which they could not recover. This is a crucial point in our investigation. We must be careful not to project our own technological trajectory onto a hypothetical predecessor. Their path to self-destruction may have followed a different route, but the chemical destination, a destabilized planetary climate system, could have been exactly the same. The mystery of the PETM remains a powerful lesson in how a civilization's peak and its demise could be recorded as a single, violent chemical spasm in the rock record. The Earth's geological archives, therefore, present us with a tantalizing but ultimately ambiguous clue. The PETM is a ghost story written in isotopic ratios, a haunting echo of our own potential future. It demonstrates that our planet has experienced events that are chemically analogous to industrial collapse. Whether this past event was natural or artificial is a question that remains at the edge of scientific inquiry. But for the purposes of our investigation into the Great Filter, this ambiguity is itself a profound finding. It proves that the chemical signature of an industrial civilization's collapse could be so massive that it is difficult to distinguish from a planetary-scale natural disaster. The act of a civilization destroying itself, in other words, looks geologically like the planet having a seizure. This realization forces us to lift our gaze from the ground beneath our feet and turn it toward the sky. If such chemical signatures are the enduring legacy of industrial civilizations, then we should be able to see them not just in our past, but in the present-day atmospheres of other worlds. For the first time in human history, we have the technology to do precisely that. Telescopes like the James Webb Space Telescope are not just taking pictures of distant exoplanets, they are conducting planetary autopsies from light years away. By analyzing the starlight that passes through an exoplanet's atmosphere, we can detect the chemical composition of its air. This has opened a new front in the search for life, moving beyond the mere search for habitable conditions to the active search for the chemical byproducts of life and technology. We are now hunting for industrial pollution on a cosmic scale, searching for the smog of alien cities. What precisely are we looking for? We are searching for molecules that have no plausible natural source, chemicals that scream factory. The ideal candidate is a molecule like a chlorofluorocarbon or CFC. On Earth, these were manufactured as refrigerants and propellants, and they had a devastating effect on the ozone layer. Crucially, they have no known natural production mechanism. Finding CFCs in the atmosphere of a distant planet would be an unambiguous sign of a currently active industrial technology. It would be the holy grail of techno-signatures, a definitive signal that we are not alone. It would also, in the context of the Great Filter, be a terrifying discovery, for it would mean we had found another civilization standing on the same precipice as we are. So as we systematically scan the atmospheres of the most promising nearby exoplanets, what have we found? The answer is as profound as it is unnerving. We have found nothing. The atmospheres we have been able to analyze, from the rocky worlds of the TRAPPIST-1 system to other Earth-sized planets in habitable zones, are pristine. They are chemically silent. We see the expected signatures of carbon dioxide, methane, and water vapor, but we do not see the chemical smog of industry. There are no cosmic CFCs, no overwhelming signatures of synthetic pollutants. The great silence, which we have long associated with the absence of radio signals, has a chemical counterpart. The universe, it seems, is not just quiet, it is also remarkably clean. This chemical silence is a monumental piece of evidence in our investigation. It suggests that the number of civilizations currently in their industrial phase within our galactic neighborhood is zero. This could mean one of several things. Perhaps industrial civilizations are so astonishingly rare that we are the first, a lonely technological island in an immense cosmic ocean. Or perhaps the industrial phase is suicidally brief. A civilization might rise, begin to pollute its atmosphere, and then drive itself to extinction in just a few centuries, a mere blink in cosmic time. Its atmospheric pollution would then be scrubbed out by natural planetary processes over the subsequent millennia, erasing the evidence of its brief, fiery existence. If this is the case, the sky would almost always look clean, because the window of active, detectable pollution is heartbreakingly short. The evidence points toward this latter, more terrifying conclusion. The universe is old. Our galaxy has had over 13 billion years to produce intelligent life. Countless worlds have had a head start of millions or even billions of years on us. The idea that we are the absolute first is statistically improbable. The more likely explanation for the pristine cosmos is that we are looking at a galactic graveyard where the chemical tombstones have long since eroded away. We are not seeing the absence of civilizations, but the aftermath. The filter this evidence suggests operates with ruthless efficiency, removing industrial societies from the galactic stage almost as soon as they appear. They do not survive long enough to permanently scar their planet's atmosphere in a way that is visible across the interstellar void. This forces us to re-evaluate our own position in a stark new light. Our own atmospheric techno-signature, our plume of carbon dioxide, methane, nitrogen oxides, and trace industrial gases, is currently broadcasting our existence to anyone with a powerful enough telescope. We are, at this very moment, a chemical flare in the cosmic darkness, announcing the presence of a young, technologically turbulent species. The silence from all other stars suggests that such flares do not last long. They are the brief final fireworks display of a civilization that has unlocked immense power, but lacks the wisdom to control it. The clean atmospheres of our neighbors are not a sign of an empty universe, but a warning that the path we are on leads to a swift and silent end. The chemical investigation has thus led us to a powerful convergence of evidence. On Earth, we find geological events like the PETM, which show that our planet's history contains episodes of rapid, global-scale climate disruption that are chemically analogous to our own industrial impact. These events are a warning from our own deep past. When we look to the stars, we find a profound lack of any such industrial activity happening now. The pristine atmospheres of exoplanets are a warning from our cosmic neighbors. The message from the past and the message from the present are the same. The stage of development we have just entered is the most dangerous one imaginable. It is the point at which a species gains the ability to rewrite the chemistry of its own world. We have now followed two major lines of evidence, the geological and the chemical. The geological record of Earth and Mars taught us that life is resilient, but that planets can fail. This ruled out natural disasters as the ultimate filter. Now the chemical record, both terrestrial and cosmic, has pointed the finger of suspicion directly at technology itself. The chemical fingerprints of industry are the calling card of the great filter. The evidence suggests that the acquisition of global-scale industrial power is the universal test that intelligent life faces, and the silence of the cosmos suggests that it is a test that no one, as of yet, has survived. Do you believe these ancient myths are just stories, or are they the echoes of a real forgotten history? Are the tales of Atlantis, of a great flood, or of a tower whose ambition led to ruin merely the products of human imagination? Or could they be the fragmented, distorted memories of a prior global cataclysm, a cultural echo of an event like the PTM? Share your perspective below. Our investigation must now turn inward, from the chemical composition of planets and atmospheres to the very structure of the intelligent minds that inhabit them. We have identified the weapon, technology, but we must now understand the motive. Is there something inherent in the nature of intelligence itself, in its ambition and its hubris, that makes self-destruction not just a risk, but an inevitability? The final clues may not lie in the rock or the sky, but in the stories we tell ourselves. Our investigation now leaves the sterile, silent evidence of atmospheric chemistry and plunges into the most complex, chaotic, and perhaps most revealing archive of all, the human mind. Having examined the physical world for scars of past catastrophes, we now turn to the cultural world, searching for the echoes of those same events in our oldest stories, our most sacred myths, and our most inexplicable artifacts. This is a more treacherous path, one where data is replaced by allegory and hard evidence by haunting intuition. But what if the great filter is not just a future event we can predict with science, but a recurring trauma so profound that it has left a permanent imprint on our species' collective consciousness? What if our myths of deluge, hubris, and downfall are not mere fictions, but the fragmented, dreamlike memories of a cycle of technological ascent and self-destruction that has played out before? We are now searching for the ghost in our own machine, the cultural DNA of a catastrophe we instinctively fear because, on some deep archetypal level, we remember it. The first and most pervasive of these cultural echoes is the story of a great flood. This is not the tale of a single culture, but a foundational myth for all of humanity. In the Mesopotamian epic of Gilgamesh, the sage Utnapishtim builds an ark to survive a deluge sent by displeased gods. In the Hindu Puranas, the wise Manu is warned by the god Vishnu of a world-ending flood, instructed to build a great boat, and becomes the progenitor of the new human race. The Greek myth of Deucalion and Pyrrha tells a nearly identical story of survival and rebirth on a cleansed earth. We find this narrative archetype repeated with uncanny consistency across continents and oceans, from the indigenous peoples of the Americas to the Aboriginal tribes of Australia. While the details shift, the core structure remains immutable: a global civilization grown corrupt or arrogant, a divine or natural warning, a cataclysmic cleansing by water, and a handful of survivors who carry the seeds of a new world. This universality is itself a profound clue, demanding an explanation beyond mere coincidence. Orthodox anthropology and geology provide a plausible, if partial, explanation for this mythic convergence. The end of the last ice age, around 11,700 years ago, was a period of dramatic and terrifying climate change. As the great continental ice sheets melted, global sea levels rose by over 120 meters, inundating vast coastal plains where early human settlements likely thrived. Events like the sudden collapse of glacial lakes, such as Lake Agassiz in North America, would have unleashed floods of unimaginable scale. The Black Sea deluge hypothesis suggests that the Mediterranean breached the Bosporus Strait around 7,500 years ago, violently flooding a freshwater lake and displacing countless communities. These regional catastrophes, experienced by our scattered ancestors across the globe, could certainly have been the seeds from which the universal flood myth grew. But this explanation feels incomplete. It accounts for the water, but not for the consistent moral dimension of the story. The theme of a civilization being wiped out as a direct consequence of its own hubris and technological overreach. This is where our investigation must push deeper, reinterpreting the flood myth through the lens of the Great Filter. What if the rising waters are an allegory for a different kind of unstoppable, self-inflicted cataclysm? The story is never just about a natural disaster, it is about a systemic failure. The world before the flood is always described as a place of great advancement that has lost its way, a civilization whose knowledge has outstripped its wisdom. The flood is a planetary reset button, a consequence not of sin in a religious sense, but of a fundamental imbalance with the natural order. In this reading, the Great Flood is the archetypal memory of a filter event. It is the story of a civilization that reached a certain technological threshold, destabilized its planetary environment, whether through climate change, warfare, or some other means, and was consequently erased, leaving behind only a whispered, traumatized warning passed down through generations, a story that would later be draped in the metaphors of divine wrath and rising seas. From the realm of universal myth, our inquiry now turns to a more specific and unsettling category of evidence: anomalous knowledge. We find across numerous ancient cultures a startlingly sophisticated understanding of astronomy, a level of celestial awareness that seems utterly incongruous with their supposed technological level. The most famous and controversial case is that of the Dogon people of Mali in West Africa. According to ethnographers in the 1930s and 40s, Dogon mythology contained detailed, specific knowledge of the Sirius star system. They knew that Sirius, the brightest star in our sky, had a companion star, Sirius B. They described this companion as invisible, incredibly heavy, and possessing a 50-year elliptical orbit. Every single one of these claims, impossible to verify with the naked eye, has been confirmed by modern astronomy. Sirius B is a white dwarf, its existence not even photographed until 1970. How could a pre-industrial society possess this specific, quantitative astronomical data? The mainstream scientific explanation, championed by figures like Carl Sagan, is one of cultural contamination. The theory posits that the Dogon acquired this knowledge from European visitors, such as missionaries or anthropologists, in the early 20th century. A visiting astronomer could have shared the latest findings about Sirius, which were then skillfully woven into the existing fabric of Dogon mythology by their elders, creating a new, modern layer to their ancient traditions. This is a plausible and scientifically parsimonious explanation. However, it does not fully satisfy the mystery. The knowledge appears deeply embedded in the Dogon's oldest rituals and symbols, suggesting an origin that predates modern European contact. The controversy remains a flashpoint between orthodox skepticism and the possibility of a deeper historical anomaly. For our investigation, it serves as a powerful "what if?", a potential data fragment from a lost era of high knowledge. Let us entertain for a moment the more radical possibility. What if the Dogon's knowledge is not a modern contamination, but an ancient inheritance? Not a message from extraterrestrials, but a legacy from a forgotten terrestrial chapter of high technology. In this scenario, a previous advanced civilization would have possessed detailed astronomical charts. In the aftermath of its collapse, the filter event, the vast majority of its science would be lost, but small, resilient pockets of knowledge might survive, not in libraries of data, but as sacred lore. Passed down through generations of oral tradition, the science would be stripped of its original context, becoming myth. The physics of a white dwarf's density becomes the story of the heaviest star. The mathematics of an orbital period becomes the timing for a 50-year religious festival. The Dogon mystery, then, could be an example of a message in a bottle, a piece of high science that survived a planetary cataclysm by disguising itself as religion, a ghost of lost astronomy haunting a tribal mythology. This pattern of anomalous knowledge is not confined to the Dogon. The ancient Sumerians, in their earliest cylinder seals, appear to depict our solar system with a startling accuracy, showing the planets in their correct relative positions and sizes, including Uranus and Neptune, which were not officially discovered until the 18th and 19th centuries. The Mayan calendar, with its intricate and interlocking cycles, tracked the synodic period of Venus with an accuracy of just a few hours over 500 years and calculated the length of the solar year more accurately than the calendars used in Europe at the time. Across the globe, from the pyramids of Egypt to the megalithic structures of Britain, we see an obsession with celestial alignment and the precise tracking of astronomical cycles like precession. While each case can be explained individually through generations of patient observation, the cumulative weight of this evidence suggests a profound, almost global, preoccupation with the heavens, a level of focus and mathematical precision that seems to exceed the practical requirements of early agricultural societies. This brings us to the most tangible and frustrating clues in our cultural investigation: out-of-place artifacts, or upats. These are physical objects, often of stunning technological sophistication, found in archaeological contexts that suggest they are thousands or millions of years older than the conventional timeline of technology would allow. The vast majority of these are easily debunked as misidentified natural formations, modern creations, or outright hoaxes. Yet, after filtering out the noise, a small number of these artifacts remain genuinely enigmatic, challenging our neat, linear conception of history. They are like single, perfectly machined gears found in a box of stone tools, hinting at a lost chapter of engineering, a story of technological development that was not a straight, unbroken line of progress, but a series of peaks, collapses, and near-total erasures. The undisputed king of all upats, the one piece of evidence that has stood up to a century of intense scientific scrutiny, is the Antikythera mechanism. Discovered in 1901 by sponge divers in a Roman-era shipwreck off the coast of a Greek island, this device is nothing short of breathtaking. It is a shoebox-sized assembly of at least 30 interlocking bronze gears of extraordinary complexity. For decades, its true function was a mystery, but with the advent of modern imaging technology, scientists have been able to peer inside its corroded shell and reconstruct its purpose. The mechanism was a highly sophisticated astronomical computer. By turning a single crank, its user could track the positions of the Sun, the Moon, and the 5 visible planets, predict solar and lunar eclipses with stunning accuracy, and even track the 4-year cycle of the ancient Olympic Games. It was a miniature mechanical cosmos, a clockwork mind built by ancient Greeks. The profound anomaly of the Antikythera mechanism is not just its existence, but its isolation. It represents a level of miniaturized precision mechanical engineering that appears to come out of nowhere and then vanishes completely. Nothing else like it has ever been found from that era. Its sophistication would not be seen again in human history for over 1,400 years, with the astronomical clocks of medieval Europe. It is a ghost from a lost world of Hellenistic science, a testament to a technological path that was abruptly abandoned and forgotten. It forces us to ask a deeply unsettling question. What other knowledge, what other technologies were lost along with it? The device is a tangible demonstration that a society can achieve a peak of technical genius and then have that knowledge utterly erased from history, leaving behind only a single miraculous relic by sheer chance. The Antikythera mechanism serves as a perfect small-scale model for a great filter event. It demonstrates the profound fragility of technological knowledge. Imagine a global collapse, a planetary fever like the PETM, or a nuclear winter, or a bioengineered plague. The complex supply chains, the specialized educational systems, the digital infrastructure required to maintain our own technological society would be the first things to disintegrate. How many generations would it take for the ability to manufacture a microchip or sequence a genome to be lost forever? Our most advanced knowledge would vanish, leaving behind only the most durable and simple technologies. Future archaeologists might find the ruins of our cities, but the science that built them would be gone. The Antikythera mechanism is a warning written in bronze. It shows that technological regression is not just a possibility, it is a historical reality. A single shipwreck was all that saved this one piece of genius from total oblivion. When we assemble these disparate cultural clues, the universal myth of a world-ending flood, the anomalous astronomical knowledge embedded in ancient lore, and the tangible reality of sophisticated technology being lost to time, a coherent picture begins to emerge. They are all different symptoms of the same underlying phenomenon, the cyclical nature of civilization. Our modern belief in a linear, inexorable march of progress may be a dangerous illusion. The cultural and archaeological record is instead whispering a story of rise and fall, of technological peaks, followed by catastrophic valleys of regression and forgetting. These are the echoes of smaller filter events, the near misses and regional collapses that our species has endured and partially remembered. They are the scars on our collective memory, warnings of a pattern that we seem doomed to repeat on an ever larger and now planetary scale. These myths and artifacts are not, therefore, evidence of a specific, lost super-civilization like Atlantis. To interpret them so literally is to miss the point. Their true significance is more profound and more relevant to our own fate. They are the emergent product of an intelligent species grappling with the inherent dangers of its own ingenuity. The Tower of Babel myth is not the memory of a real tower. It is a brilliant parable about how the ambition for a unified global technological project can lead to fragmentation, miscommunication, and collapse. The story of Icarus is not about a boy with wax wings. It is a timeless warning that our ability to innovate often outpaces our wisdom to use that innovation safely. These stories are the foundational software of human consciousness, and they are all flashing the same error message. Unchecked technological ambition leads to self-destruction. This loop of our investigation, then, concludes not with a definitive answer, but with a deeply unsettling convergence. The geological record showed us a planet prone to violent fevers that mimic industrial collapse. The chemical survey of the cosmos showed us a galaxy eerily devoid of the industrial pollution that should accompany advanced life. And now, our own cultural record reveals a psyche haunted by memories of cataclysm and a deep, instinctual fear of our own technological hubris. We have examined the evidence from the rock, from the sky, and now from the soul. All three lines of inquiry point to the same suspect. The great filter is not an external barrier. It is an internal one, woven into the very fabric of technologically capable intelligence. The investigation has led us back to ourselves, to the precipice of our own making. It is now time to synthesize these findings and render a verdict. Our investigation now pivots from the sterile, silent evidence of atmospheric chemistry and plunges into the most complex, chaotic, and perhaps most revealing archive of all, the human mind. Having examined the physical world for scars of past catastrophes, we now turn to the cultural world, searching for the echoes of those same events in our oldest stories and most sacred myths. This is a more treacherous path, one where data is replaced by allegory and hard evidence, by haunting intuition. But what if the great filter is not just a future event we can predict with science, but a recurring trauma so profound that it has left a permanent imprint on our species' collective consciousness? What if our myths of deluge, hubris, and downfall are not mere fictions, but the fragmented, dreamlike memories of a cycle of technological ascent and self-destruction that has played out before? We are now searching for the ghost in our own machine, the cultural DNA of a catastrophe we Instinctively fear because on some deep archetypal level, we remember it, or perhaps more terrifyingly, we foresee it. Consider the ancient story of the Tower of Babel. In its conventional telling, it is a simple fable of divine punishment for human arrogance. But when viewed through the lens of our investigation, it becomes a stunningly precise parable for a technological filter event. Humanity, united by a single language and purpose, begins a grand technological project to build a city and a tower with its top in the heavens. This is the story of a globalized Type 1 civilization, harnessing planetary resources for a singular, ambitious goal. The failure does not come from an external enemy or a natural disaster. It comes from within. The project collapses due to a breakdown in communication, a loss of shared purpose, leading to fragmentation, confusion, and the scattering of the people across the earth. The myth of Babel is the story of a global system becoming too complex and interconnected, collapsing under the weight of its own ambition. It is a perfect diagnosis of how a civilization's greatest strength, its ability to cooperate on a global scale, can become its fatal vulnerability. This theme of technological self-destruction is echoed in the more personal, intimate myth of Icarus. Daedalus, the master inventor, creates wings of feather and wax, a marvel of engineering that grants his son the power of flight. This is the allegory of technological inheritance, of one generation bestowing immense new power upon the next. Daedalus gives a clear warning: do not fly too high or too low. It is a rule book for the responsible use of world-altering capability. But Icarus, intoxicated by the sheer ecstasy of his newfound power, forgets the warning. He soars higher and higher, driven by the thrill of his own ability, until the sun, the unforgiving reality of physical law, melts the wax that holds his creation together. His fall is swift and final. The story of Icarus is a timeless warning that the capacity to innovate will always outpace the wisdom to control that innovation. It is the fundamental human tragedy, a story that tells us our own genius is the most seductive and dangerous force we will ever encounter. Nowhere is this archetype of a technologically advanced civilization causing its own demise more potent than in the legend of Atlantis. While often dismissed as mere fantasy, the persistence and power of the Atlantis myth point to a deeper psychological truth. The story, as first told by Plato, is not of a primitive paradise, but of a highly advanced maritime empire with engineering and social structures far beyond those of its contemporaries. Yet, its downfall is explicitly moral and internal. The Atlanteans, through their hubris and technological might, grew corrupt and sought to conquer the known world. Their punishment was a cataclysm of fire and earthquakes that sank their entire civilization beneath the sea in a single day and night. Atlantis is the ultimate ghost in our collective memory, the archetypal story of a civilization that reaches the pinnacle of achievement and then vanishes so completely that its very existence becomes a debate. It is the perfect, mythic encapsulation of a great filter event, a peak of technological power, followed by a sudden, total, and self-inflicted erasure from history. The convergence of these myths across disconnected cultures is the final piece of evidence in our investigation. The Tower of Babel, Icarus, Atlantis, the Great Flood narratives, they are all telling the same story. They are not independent inventions, but rather different cultural expressions of a single, profound, and deeply human intuition, that the path of technological development contains an inherent, almost inescapable self-destruct mechanism. These are not memories of a specific lost civilization. They are the emergent wisdom of a species that has for millennia been grappling with the dangers of its own cleverness. They are a form of cultural premonition, a psychological immune system trying to warn us against a predictable failure mode of intelligence. These ancient stories are the foundational software of human consciousness, and they are all flashing the same timeless error message: unchecked ambition, powered by accelerating technology, leads to ruin. The filter is not something that happens to us, it is something we do to ourselves. This ancient pattern of myth-making continues today, taking new forms in our modern folklore, science fiction. Our cultural obsession with post-apocalyptic landscapes, rogue artificial intelligence, genetically engineered plagues, and ecological collapse is not simply a taste for dark entertainment. It is the contemporary manifestation of the same archetypal fear. We are still telling the story of Babel, but now the tower is the interconnected global internet, vulnerable to a catastrophic crash. We are still telling the story of Icarus, but his wings are now made of artificial general intelligence and CRISPR gene editing tools. Our most imaginative minds are drawn again and again to envisioning the precise mechanisms of our own potential downfall. This is not a failure of imagination, but its greatest and most terrifying success. It is our species' subconscious, working tirelessly to map out the contours of the great filter that it instinctively knows is lying directly in our path. This, then, is the final shocking clue. It is not an artifact of stone or a chemical signature in a distant sky. It is an echo in our own minds. The geological record showed us a planet that has endured fevers analogous to industrial collapse. The cosmic survey revealed a galaxy unnervingly clean of the industrial waste we should expect to see. And now, our own cultural record, from ancient myth to modern fiction, reveals a species haunted by a profound and persistent premonition of its own technological self-destruction. The other clues were external, circumstantial. This one is a confession. The suspect in this cosmic crime, technological intelligence itself, appears to have a deep, innate understanding of its own fatal flaw. The fact that we have been telling ourselves this same warning story for thousands of years is the final confirmation. The investigation has led us from the stars back to ourselves, and the evidence within is as compelling as any found in the rock or sky. The time for gathering evidence has concluded. The disparate clues collected from the bedrock of two worlds, the silent void between the stars and the deepest recesses of our own collective mind, now lie before us on the table of inquiry. Our investigation has reached its final critical stage, the great synthesis. We are no longer detectives searching for leads. We are the jury, tasked with assembling these fragments into a single, coherent image. We began with a fossilized microbe, a whisper of life 300 million miles away, and followed its trail through deep time and cosmic space. Each piece of evidence has systematically eliminated a suspect, narrowing the field of possibilities until only one terrible conclusion remains. We must now connect these threads and look upon the complete picture they have formed, for it is a picture not of a distant alien species, but a stark and unforgiving portrait of ourselves. Our case began with the impossible clue from Bright Angel, the fossil that should have been a cause for universal celebration. The discovery of microbial life on Mars was the definitive answer to a question we have asked for millennia. But its true significance was not in what it revealed, but in what it disproved. For generations we held on to the comforting hope that the great filter was behind us, that the initial spark of abiogenesis was so miraculously rare that we were the first and perhaps only intelligent beings to arise in this galactic wilderness. The Martian fossil annihilated that hope. It demonstrated with chilling finality that the genesis of life is not the filter. If it could happen twice in one solar system, it must be a common, almost inevitable outcome of planetary chemistry. This was the first critical step in our investigation, the elimination of our most cherished alibi. The good news of life's abundance was, in fact, the worst news imaginable, for it meant the true barrier must lie somewhere ahead of us. This forced our investigation to the geological records, treating Earth and Mars as two witnesses. Mars, the planetary tombstone, told a story of a world that passed the test of Genesis but failed the test of endurance, its life support systems collapsing as its magnetic heart grew cold. This presented a plausible filter, planetary infertility. Yet, Earth, our own world, stood as a powerful counter-witness. Its 4.5 billion-year history is a saga of survival against the most extreme forms of natural violence. Life on this planet endured the Great Dying, a slow planetary poisoning that extinguished over 90% of all species. It survived the Chicxulub impactor, a cosmic blow that plunged the world into darkness. The testimony of Earth's rock was clear. Natural catastrophes, both internal and external, are immense hurdles, but they are survivable. Life, once it takes hold on a sufficiently robust world, is a force of incredible tenacity. This eliminated our second major suspect. If life can withstand nature's worst, then the great filter must be something unnatural. With natural causes ruled out, we lifted our gaze to the cosmos, searching for the fingerprints of the unnatural. Technology. For decades, we have listened for radio signals and found only the great silence. More recently, with telescopes of astonishing power, we began to perform atmospheric autopsies on distant worlds, hunting for the chemical smog of alien industries. We found nothing. The cosmos, as far as we can see, is chemically pristine. This is not an absence of evidence, it is a monumental piece of evidence in itself. It is the eerie quiet of a crime scene that has been wiped clean. The conclusion is inescapable. The industrial phase of a civilization, the very stage we have just entered, must be catastrophically brief. Civilizations either do not reach it, or they do not survive it for long. They flare up, poison their worlds, and then vanish before their chemical scar can become a permanent feature of the galactic landscape. The silence is a graveyard, where the tombstones have long since faded. The final line of inquiry turned inward, from the physical world to the world of myth and archetype. If the filter is indeed a predictable act of technological self-destruction, we reasoned that some echo of this truth, some premonition, should exist within our own consciousness. We found it woven into the very fabric of our oldest stories. The Tower of Babel is not a tale of architecture, but a parable of a globalized system collapsing under its own complexity and ambition. The myth of Icarus is a timeless warning that our power to innovate will always outpace our wisdom to control it. The legend of Atlantis is the archetypal memory of a civilization that achieved the pinnacle of technological might, only to be erased by its own hubris. These stories, repeated in endless variation across every human culture, are a confession from our collective subconscious. They reveal a species that has a deep, instinctual, and terrifying understanding of its own fatal flaw. Now, we assemble the pieces. The Martian fossil proved the beginning is not the filter. The resilience of life on Earth proved that the journey through natural catastrophe is not the ultimate filter. The pristine, silent cosmos proved that no one appears to survive the technological endgame. And our own myths revealed a profound, innate fear of this exact fate. When placed together, these four lines of evidence converge on a single, inescapable conclusion. The great filter is not an external event. It is an emergent property of intelligence itself. It is the inevitable crisis point that every civilization reaches when its technological power, the ability to split the atom, to rewrite the genetic code, to alter the global climate, overwhelms its social and moral maturity. The filter is the final, predictable consequence of a clever species becoming too powerful for its own good. The specific mechanism of this filter is almost irrelevant, for there are so many plausible candidates, each one a spectre of our own creation. It could be the swift final verdict of thermonuclear war, a single afternoon of madness that erases a billion years of evolution. It could be the slower, more agonizing collapse of the biosphere under the weight of industrial pollution, a planetary fever from which there is no recovery. It could be the creation of a runaway artificial intelligence, a mind of our own making that quickly renders its creators obsolete or extinct. Or it could be a genetically engineered plague, a tool of healing turned into a weapon of perfect lethality. These are not separate risks. They are the many heads of the same hydra. They are the predictable failure modes of a species whose hands have grown more powerful than its heart has grown wise. There remains one last desperate hope, a scientific escape route that could reframe this entire terrifying picture: panspermia. This is the hypothesis that life did not begin independently on Earth and Mars, but rather originated on one and traveled to the other, perhaps aboard a meteorite. If this were true, it would mean that the genesis of life in our solar system was a single, rare event after all. It would allow us to place the great filter back where we have always wanted it, in our deep past. It would make us special again, the lucky survivors of a cosmic lottery. But this feels less like a probable explanation and more like a comforting fantasy, a last-ditch effort to deny the overwhelming weight of the converging evidence. Even if panspermia were true, it does not explain the great silence beyond our solar system, nor does it quiet the cautionary whispers in our own myths. It is a fragile shield against a far more robust and terrifying conclusion. So the image is now complete. The universe is a vast cosmic laboratory, running the same experiment over and over, and the result is always the same. A planet forms in the habitable zone. Life begins. It evolves, growing more complex, surviving every natural challenge. Eventually, intelligence emerges. It discovers science, builds tools, and creates a global technological civilization. It then reaches for the power of the gods, and in doing so, unleashes its own destruction. The fossil at Bright Angel on Mars is a monument to the beginning of this process. The profound echoing silence of the galaxy is the monument to its end. We are the first species, as far as we know, to be able to see both monuments at the same time. We are the first to be able to read the warning. The investigation has led us full circle, from a single cell on a distant world back to our own. The evidence from geology has provided an alibi for nature. The evidence from cosmology has provided the testimony of countless missing witnesses. The evidence from our own culture has provided a psychological confession. When viewed together, they form an open and shut case. The greatest threat to intelligent life is intelligent life itself. We went searching the cosmos for the reason why the universe is so empty, and we found that the reason is a mirror. For millennia, we have stared at the stars and asked, "Where is everybody?" The chilling answer, implied by all the available data, is that they are where we are headed. The discovery on Mars, therefore, was not the opening of a new chapter of cosmic exploration. It was the closing of a case file. It has allowed us to solve the Fermi paradox, and the solution is the most sobering one imaginable. The funeral bell we hear ringing from the silent cosmos is not for some unknown alien race. It is for us. We are not the first to walk this path. We are simply the most recent species to arrive at the precipice, the next in a long line of cosmic tragedies. The evidence has been presented, the arguments made. The complete picture shows a universal pattern, a cycle of ascent and self-destruction that no one anywhere has ever broken. The great synthesis is this: the fossil on Mars is our shared past, a testament to a common origin for life. The silent empty sky is our probable future, a testament to a common destiny for intelligence. We have, through our own ingenuity, found the universe's final warning sign. The terrible irony is that we found it at the exact moment in our history when we ourselves are accelerating toward the very cliff edge it warns us about. The investigation is over. The verdict is in. The only question that remains is not what the filter is, or where it is, but whether, for the first and only time in the history of this galaxy, it can be survived. The investigation is complete, but the inquiry has just begun. The evidence gathered from the bedrock of 2 worlds and the silence of 1 billion stars has not brought us comfort or resolution. Instead, it has held up a mirror. In one hand, we see the reflection of a fossilized microbe from Mars, a grainy image of our own humble biological beginnings, a testament to the common, almost mundane origin of life. In the other, we see the reflection of a vast and empty sky, a perfect, polished black mirror showing us the probable end of all who follow this path. We are suspended between these 2 reflections, between a common origin and what appears to be a common destiny. For the first time in our history, we are forced to see ourselves not as the heroes of a unique cosmic drama, but as the latest actors in a tragedy that has played out countless times before. The question, "Are we alone?" has been answered with the most terrifying irony. No, and that is the problem. This newfound knowledge forces us to redefine our place in the universe. We are not the children of a miraculous conception, but the survivors of a brutal cosmic gauntlet. We are the descendants of a lineage that endured planetary freezes, asteroid impacts, and near-total extinctions. This history has imbued our species with a deep and dangerous sense of exceptionalism, a belief that we are destined to overcome any obstacle. But the evidence of the Great Filter suggests this is the ultimate fatal illusion. Our resilience against natural threats is precisely what qualified us to face the final, unnatural one. We have not been climbing a ladder of progress toward the stars. We have been walking a plank, blindfolded, over an abyss of our own making. The silence of the universe is not a challenge to be conquered. It is a memorial to all those who shared our arrogance. What, then, is the meaning of human civilization in the face of this terrible symmetry? If the arc of intelligent life bends inexorably toward self-destruction, is our art, our science, our love, all for nothing? Perhaps not. Perhaps our true significance, the one thing that might distinguish us from the silent chorus of the fallen, is the ability to be the first to understand the pattern. We are the first species, as far as we know, to have developed the tools to read the geological history of our world, to analyze the chemistry of distant ones, and to see the profound warning that connects them. Consciousness has bestowed upon us the curse of foresight. We are the first civilization to be able to look at the filter and call it by its name. This knowledge is an unbearable burden, but it is also the only key we have to a lock that has, until now, been unbreakable. This reframes our entire conception of progress. For centuries, we have defined our advancement by speed, by growth, by the accelerating power of our technology. We have raced to consume our planet's resources, to build taller towers, to unlock more powerful forces, believing that this relentless forward momentum was the very definition of success. The Great Filter suggests that this is a fatal miscalculation. The test of a truly advanced civilization may not be its ability to reach for the stars, but its wisdom to pull back from the fire. The ultimate technological achievement may not be interstellar travel, but the creation of a stable, sustainable, and self-aware society that can endure for eons on its homeworld. The challenge is not to go faster, but to learn how to stop. It requires us to dismantle the very altar of progress upon which we have worshipped for generations. This is the precipice upon which we now stand. The fossil at Bright Angel is a message from our shared past. It tells us that the universe is not barren but fertile ground, ready to seed life wherever it can. The silence of the stars is a message from our probable future. It tells us that intelligence, in its adolescent phase, is a planetary disease for which there is no known cure. We are living in the brief, turbulent window between these two messages, between the diagnosis and the prognosis. We are the first to be able to read both. This may be our only true claim to being special, not that we are immune to the filter, but that we are the first to be given the chance to see it coming. The universe has finally shown us the rules of the game, and it has done so at the exact moment our own hand is reaching for the piece that will trigger the checkmate against ourselves. The weight of this knowledge is crushing because it is not abstract. It recasts every aspect of our present reality. Our political squabbles, our economic competitions, our tribal conflicts, they all seem like children, arguing in a house that is slowly, silently filling with gas. Every weapon we build, every ton of carbon we release into the atmosphere, every ecosystem we push to the point of collapse, is another vote cast in favor of the Great Silence. We are no longer a young species taking its first tentative steps into a hopeful future. We are a civilization on trial, and every action we take is evidence submitted to the cosmic jury. The verdict on our species will not be written by some external judge, but by the sum total of our own choices in this critical, fleeting century. Therefore, the story of the Great Filter is not ultimately about aliens or distant stars. It is the story of a choice that now confronts every one of us. It is the choice between the short-term seductive thrill of unchecked power, the flight of Icarus, and the long-term difficult wisdom of restraint. We have spent our entire history looking outward for answers, but the final question is an internal one. Can a species that evolved through competition and expansion learn to cooperate and conserve? Can a mind built for the immediate urgencies of survival learn to think on geological timescales? Can we, in short, become a different kind of creature than the one we have always been? The fossil on Mars shows us our common biological origin. Does the absence of advanced life everywhere else have to show us our common, unchangeable destiny? Our journey through deep time ends here, but the quest for answers is eternal. We are the generation that found the warning sign, a discovery that will echo through whatever future we have left to write. It is a legacy of both profound discovery and profound dread, a final examination for which we have been given all the questions in advance. The path forward is shrouded in uncertainty, balanced on the knife's edge of our own wisdom and folly. The silence of the cosmos is waiting for our answer. It is waiting to see if we will become just another echo in the void, or the first faint sound of something new. If you believe this forgotten story needs to be told, help us by sharing this documentary, liking, and subscribing for the next chapter in our exploration. Thank you for traveling with us.